The aldol condensation would be an important reaction in this chapter in general. The aldol condensation occurs in, well, condensation first. What's that? That would be loss of water, so minus H2O. So from the molecules that are coming together, there is a molecule of water lost. So we can do this in basic or acidic conditions. So in base, we form an enolate, as the name implies. And in acid, it's an enol. Okay? The product will contain an aldehyde or ketone group and the alcohol, the hydroxyl of an alcohol. And I say it this way because aldol comes from aldehyde, Al, and all from the alcohol, aldol. Okay? The product then may go on to dehydrate to an alpha-beta unsaturated carbonyl. So I'll show you that. But the whole thing is an equilibrium process, which means each step is reversible. So if we consider the aldol process, we could look first at this example. This is just acetone, and any molecule of acetone, we could take a base and remove a proton. That could form the enolate, which attacks the carbonyl of another molecule that's present. And then we form this new bond. And that is substituting the H on one molecule for a carbon of another molecule. And you can see there's the aldehyde, or actually a ketone, carbonyl. And there's the alcohol. So aldol is where the name comes from. So there's only about 1% of this at equilibrium. We can consider ways that it would push forward in the presence of Le Chatelier's influence. So let's start with the mechanism of this reaction in base. So what you can see, we would take hydroxide or some base and remove a proton, and those electrons will shift onto the carbon. That will give us a lone pair out on this carbon. And then if you take a look at this, you can also see there are resonance forms we can write, and that's how we get the negative charge out onto the oxygen. So this is an enolate, So then what can happen, and of course that's a resonance pair, then what can happen is we'll take that enolate, and I'm going to draw this one, and have it attack another molecule that's present that hasn't become an enolate. So remember, this is equilibrium conditions. So only part of this mixture, there's our forward direction, has become an enolate. So what will happen is we'll have our electrons swing back, and then those can attack. You can also use this form of the enolate and attack directly. And we should get our, I'm going to change this CH3 to just a line. And then that will be our CH2. And then we have a new bond to our CO minus. And in this, let's see, I should have also written this as equilibrium. We can have that add a proton from the water that formed back here. Take the proton, and we get our aldol product, ALDOL, and hydroxide back. So that was a catalytic process.